Okay, now let's find where all these special angles cross the unit circle. The beauty of the unit circle is that the radius is 1. And if we look at what the sine of theta is, well, that's y over r. The cosine of theta is equal to x over r. So if the radius is 1, the sine of the angle is going to just be the y-coordinate of where it crosses the unit circle. And the cosine of the angle is just going to be the x-coordinate of where the angle crosses the unit circle. Okay? So, first let's look at 0 degrees. Alright, that's already given to us. Alright, so 1 comma 0. So that tells us that the cosine of 0 is 1 and the sine of 0 is 0. Okay? Now if you place your 30-degree triangle here, it would look something like that. Okay? Where this is 30 and this is 1/2 and this is root 3. So the x-coordinate of this point is going to be root 3 over 2, and the y-coordinate is going to be 1/2. So like where a 30-degree angle crosses the unit circle is going to be at the point root 3 over 2, comma 1/2. Right, if we take our 45, 45, 90-degree triangle and place it, it would look something like this, where that's 1, this side is root 2 over 2, and this side is root 2 over 2. So we can use that to find the x and y coordinates of this point. So a 45-degree angle is going to cross the unit circle at the point root 2 over 2, comma root 2 over 2. Okay. Now I should have said this at the beginning of the video, but it's okay to look at a couple examples. But at this point, I want you to, if you haven't done so already, pause the video and continue this process until you get back around to 360. And if you feel like you're confused or getting stuck, you can play it up until the point where you're at to check how you're doing. But try to do this on your own. Try to find where all these special points cross the unit circle. And look for patterns, okay? Because once you fill out the first quadrant, it gets a little easier, alright? Okay, so if you didn't pause or you unpause, now let's look at 60 degrees. Okay, so this would be a 60, 90, 30-degree triangle. Okay, the radius is 1. This side is 1/2. This side is root 3 over 2. So we move to the right 1/2, up root 3 over 2. So this point where a 60-degree angle crosses the unit circle is going to be at the point 1/2, comma root 3 over 2. And then a 90-degree angle will look just like that. That's going to cross the unit circle at 0, comma 1. Alright, so you might recognize these, this is 0 down here, let me fix this. So you might recognize these values from your special table. Alright, that's because 0, 1/2, root 2 over 2, root 3 over 2, 1. Alright, that's the first row of your table of sine of 0, sine of 30, sine of 45, sine of 60, sine of 90. Right, the reason why those are the y-coordinates, and sine of theta is y over r, and in the unit circle, r is 1. Okay, the x-coordinates are the cosines of the corresponding angles. So you can think of it as cosine, comma sine. They go in alphabetical order, just like x, comma y. Okay, now you can use the first quadrant to find the second quadrant. Alright, so I'm going to pause the video and fill out the second quadrant, and you should too. And then when you play it, see how you did. Okay, so the second quadrant should look very similar to the first quadrant, except the x-coordinates are negative and the y-coordinates are positive. The reason why is because the triangles are the same, they're just in different directions. So like if you took this triangle here and reflected it over the y-axis, you would get that point there. And the rule for reflecting over the y-axis is negating your x-coordinates. So like all these points are just reflections of these points from quadrant 1. And then, so if you ever have to fill out the unit circle, you really just have to think about the first quadrant, and then the rest is kind of straightforward. Alright, so now, if you haven't done so yet, fill out the third quadrant, and I'm going to pause and do that myself. Alright, so there's quadrant 3, which is just the points in quadrant 2 reflected over the x-axis, so the same coordinates, except the points from quadrant 2 now have opposite y values as the points in quadrant 3. Alright, and notice how I'm color coordinating it. Alright, what do all the angles with the same color have in common? Alright, think about it, pause it, and you'll hear the answer in a second. Okay, what they have in common is that they all have the same reference angle, which is why they have the same points, all right? And that's the idea that we use to evaluate trig functions when we look at the quadrant and the reference angle. Like that's why the sine of like 30, that's why the sine of 30 is the opposite of the sine of 210, but the same thing as the sine of 150, because they all have the same reference angle. But 150 and 30 are in positive sine quadrants, 210's in a negative sine quadrant. Alright, so now it would be a good time to pause the video and try to do quadrant 4. Alright, and that is what quadrant 4's points would look like. Alright, and that's the unit circle. And at some point you might be asked to fill it out really quickly. That's because you want to think of patterns. Like, hopefully you use the triangles to help you find these points, right, by placing them and using the sides as the way to find the coordinates, and then using the quadrants as a way to figure out whether those coordinates are positive or negative. But once you get done with the first quadrant, you can use symmetry and just patterns to find the rest of them. And then once you have a unit circle, you can evaluate sine, cosine, tangent, cosecant, cosecant, and cotangent of any of these special angles. Alright, and that's what we're going to do in the next video.